Hello and welcome. In this episode, we will be covering variables in Java. So first things first, we're going to talk about a couple variables which we call primitive data types. In Java, there's 8 of them, and 6 of them are numerical. So I did a little Excel spreadsheet, and if you look up primitive data types on Google, you will see in images or even websites you find something very similar to this. Maybe even with a little bit more detail. But I just wanted to put it up myself to share with you guys. So here we have a little table. And let's go one by one and look at these different data types. So these data types, these primitive data types, they are the most basic things in Java. They hold information, and they are the building blocks of what you can do in Java with more advanced code. So first, we have what we call a Boolean. Boolean's very easy. Boolean just means true or false value. So if you have a Boolean variable, you can only have one that is true or one that is false. And this just sort of acts as a flag. So you might do something when the situation is true, or you might do something else if a situation is false. And this could be used to determine whether that situation is true or false right now. An example of declaring this would be something like this. You would do Boolean. You give its type first. Give it a name. In this case, we named it myBool, and we set it equal to true. Our second one is char, and that stands for character. This literally can only hold one character, nothing more. And don't confuse characters sort of being different than numbers in a way. That might sound a little weird, and it's a little weird actually even saying it, but not just A to Z is a character, but numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0, those are characters. You can't do math if it's a character type, because you see that more as not a number, but just sort of a character on the screen. For instance, let's say, and we're going to talk a little bit more advanced here, but let's say we had two characters, both were set to 1. If you did character A plus character B, it would not be 2, it would be 11, because they concatenate, they join together. You could think of it just thinking as if a number is a letter. So try to wrap your head around that. If it's still a little unclear, I recommend that maybe you try making a couple characters and set them equal to a number, and then fiddle around with them, and I'm sure you'll kind of get the point I'm trying to make. But the way we indicate a character is we have 2 apostrophes around each side of it. Our next one is, and now these, when I refer to order, these are in order of how much they can hold. So as it goes from 1 to 6, it grows larger in the amount of numbers it can hold. So for instance, byte. A byte is the smallest numerical primitive data type. It can only hold values -128 to 127. And you can see an example here, byte, my byte equals 100. If you tried putting like byte, my byte equals 128, you would get an error. That's out of range. Now you can see there's a short. This could be anything between -32,768 to 32,767. Then int is huge. We're getting to very large numbers now. And then that's sort of why I didn't put a range for long, float, and double, because we're getting into confusing notation that I don't want to take up much of the screen or talking time to elaborate on. But what you can just see from here, and what you should take away from this, is that byte holds the least, double holds the most, and this is the ordering of them in terms of what can hold the least and what can hold the most. So long is going to hold more than a short, int's going to hold more than a byte, byte's going to hold less than a float, and so on. You might want to remember that order, and that might even be a test question if you're sort of in an introduction to programming class right now. Pretty standard for how each of them are declared. Only difference is for a float. Sometimes it's required to put an F at the end. And the interesting thing about float and doubles is those are the only 2 that can hold a decimal. So if you tried making integer or decimal, it wouldn't let you. It would make an error. Float and decimal and double are the only two that can hold a decimal value, and that's why I illustrate it there. But yeah, you have to put in f sometimes when declaring a float after the number. So just a quick couple things about variables in general. They're case sensitive. So if you have, let's go back to IntelliJ. If you have a variable, let's make an int I equals, or hint, how about integer my int equals 1, and then you make an integer my int equals 2. Those are going to be different things. So capitalization matters. If you were to try to see what my int with a capital I equals, it would be 1, and it would not be 2. You would have to look at 1 where the I is lowercase. So capitalization does matter. A variable can begin with a $, an underscore, or a letter. And it's unable to include blank spaces. Ways around that is to use something we called camel case convention. And you'll kind of see why it's called camel case, and it's something I've been utilizing so far that you might not have realized. But what we do is we have the first word in our variable's name all lowercase, and then every word after the first letter is capitalized. Of course, you can do something like an underscore between each of them, but camel case convention is usually what is used. It is a good way in practice. Go ahead and do it, and a lot of programmers know that convention and utilize it. If you were to take away one thing from this, it's a variable's purpose is to purely hold information, hold a value, to hold data. If you have an integer set to 100, it's holding that 100 so you can use it in some way. So a variable's purpose is to hold a value. Now, if we were to declare a variable, let's really strip this down to an abstract sort of idea, or just sort of like a definition. Now, excuse me, this is the first time I'm using this, and I have really big thumbs, so it might not go across super well. But the most basic way we could look at declaring a variable or writing a variable is this sort of abstract definition. First, we'll have our data type, and we'll have our variable name. You see I'm using camel case there still, and we're going to set it equal to some value. So, as you can see, my handwriting in general is not even that good. But that's how we can generally look at how a variable is declared, because let's see, now we can do a drag and drop sort of thing. We have our data type, correct? So, for instance, we have an integer as a data type. A float is a data type. Boolean is a data type. We have a variable name. So for that, we could do my int or my float, or even just b for Boolean. And we set it equal to something every time. And then for integer, let's say 10 is a value. Here we could do 10.0. Don't forget the f. And here we can put true. So based off of this sort of idea here, we can now kind of do this drag and drop thing of, okay, let's get our data type first, then let's get a name, and then let's set it equal to a value. So if you're kind of overwhelmed with all these things, I would kind of remember this abstract sort of definition, and then you can think, okay, let's plug in stuff, and we'll actually make it a real live variable. So this also brings up the idea of reserved words in Java. There are words in Java that you can only use for specific things, so like an integer or an int in this case. That in Java means that data type. so you can't use that as a name or anything. And there's a lot of them. And I encourage you to go and research reserved words in Java so you know what you can and can't use. In practice, a lot of times you'll only be using integers and doubles in terms of numerical data types. Doubles hold most numbers or the largest number range and can hold decimals. Integers hold a pretty decently large number range and not decimals. So usually you'll see integers and doubles in most cases. Sometimes you'll see a float, but that's usually what you'll just see in terms of numerical. Also, just know for the numerical that they obey the orders of operations, or the order of operations. So parentheses, exponents, multiply, divide, add, subtract, and it does left to right. So standard mathematics. And then we come across the idea of static instance and local variables. So static variables, only thing you got to take away from this is that it has a static keyword. It's often used at the beginning of the program, maybe not even within a function or anything like that. But it's usually paired with the final keyword. So if you see something like, if you see something like static final int equals 0, something like that, or int I, didn't give it a name, equals 0, that would be a static variable. So it's just indicating it with the static keyword. Then we have an instance variable. So inside a class, you might have variables that are declared for that class. So like an integer I equals 0. They usually come right after you declare a class, and they're just utilized within the scope of the class. And you'll usually assign them a value in something we call a constructor. But those are instance variables. So basically, they're declared within a class, but not within a method. So they're not in a function. A method and function are the same thing. And they usually come right after you declare the beginning of a class. And you have a local variable. A local variable just means it's created within a function. So I know we haven't covered functions a lot, but let's just say we have a function, public void, get int, and, or let's just call it print int, create another function there, and then in here we make an integer I equals 0. That integer I, since it's declared inside that function, is a local variable. Declared means that it's made, you have that data type put in front of it, because when we want to use I, we don't have to refer to the int part anymore. We can just do I equals 2, or I equals 3 plus I, or something like that. So, or 3 plus 2. So we don't have to refer to that int part. We only have to declare that int part when we make the actual variable. So when we make a variable inside a function, that's a local variable. If we use a variable inside a function, but it's made outside of it, that's not a local variable. So just two last things I want to mention. Accessibility. In a previous video, I was talking about public a little bit. Public allows universal access to that function. There's a couple other ones, but the only other notable one is private. Private just means it's only usable within that class. So let's say this was a private function. This function would only be usable inside the boundaries of this class, and you can see the boundaries being highlighted by the curly brackets. There are two other ones. There's what's it called? There's no modifier, and then there's protected. And those have different boundaries, but the two big ones are public and private. Then, while not being a primitive data type, there's a thing called strings. And you're probably questioning this when we were talking about characters, but strings are really just an array of characters. And I know you keep hearing this concept of an array. For right now, you can just think of an array as a group of similar things. So a string is a group of characters. And in that case, that means words. So hello world. That's a string. So here you can hold an entire book's worth of words if you want it to. And it can go up to whatever your computer can really handle, honestly, in terms of how many words or letters it can store. And the only real difference is that, obviously, we have string in the front, and in this case, it's a capital S. All other types start with a lowercase letter. This one's capital, and that we have two quotes around the outside instead of just a single quote. But that's how you will store words in multiple things. Similar to how I talked about characters holding numbers, this can hold numbers too, but they're not really numbers. Just think of if a number was in the alphabet or something like that. You can't do math with them. They would just concatenate. Alright, so that's mostly it on variables. If you have any questions, feel free to drop a comment. Let me know if there's anything I can clear up or I didn't get across well enough for you to understand. Don't be afraid to let me know, and I'll keep making more videos, and I hope they're helpful. So stay tuned.